Welcome, future elementary educators. In this screencast, we're going to take a look at what we mean by volume and how volume is affected by the lengths of sides of the object we're measuring. So let's talk about the most basic of things. You have some three-dimensional object like so, and oh, this was terribly drawn. You're going to get the idea. It's an optical illusion. So you have this three-dimensional object, and you're trying to figure out what its volume is. Well, what does that even mean? Well, the volume is a measure of the space inside the object. Well, how is that measured? Well, we measure all the sides in some linear measurement, inches, centimeters, feet, whatever. So we think about 1 cubic unit of that length. So if we measured in centimeters all the way around, we picture this object that happens to be 1 cubic centimeter. 1 cubic centimeter. It's a cube and it's 1 centimeter on a side. Volume is the number of unit cubes that can fit inside the object. And for these purposes, we'll let you squish the cubes, change the shape of the cubes, cut the cubes up. We imagine that the cubes are made out of some gelatinous substance that can be squished and reshaped and reformed so that the volume is the precise number of unit cubes that can be jammed into, crammed into, squished into the object exactly without overflowing. This is what we mean by volume. So when we go to talk about objects like this cylinder, and you try to tell me, wait a minute, square things can't fit completely in a circular cylinder, I'm going to say, yeah, but the square cubes are all made out of some substance that's easily malleable, Play-Doh, you name it, and we can squish them all in here and fill the solid precisely. Okay? Okay, so let's consider the most basic of things. Let's look at the prism. The rectangular prism. Let's make this 3 centimeters and let's make that 4 centimeters and let's make this 10 centimeters. And let's see if we can find the volume of the prism. Well, if we're looking to stack unit cubes, we can put 3 unit cubes along this side and we can put 4 unit cubes along this side. So the base of our unit cube solid, the base has 12 unit cubes, right? The base. So how many of those can we stack on top of each other to get 10 centimeters? Well, we can put 10, right? We can put 10 stacks of 12 and fill the prism completely. So the volume of the prism is 3 times 4 times 10. That's 120 cubic centimeters. More generally, the volume of a prism is its length times its width times its height, or if you like, the area of the base times the height. This is one of those things that we teach young people. This is a grade 5 standard. 5th graders are expected to find the volume of a prism and to connect it to this very idea that we have these unit cubes and they fill the solid completely. So let's do this. Here is a rectangular prism, and it is 4 inches by 6 inches by 8 inches. And here is a rectangular prism, and it is 2 inches by 3 inches by 4 inches. Take a moment, hit the pause button, find the volumes of each, and decide what the relationship between them is. So I'm hoping that you figured out that 4 times 6 times 8 is 192 cubic inches. And I'm hoping that you found that 2 times 3 times 4 is 24 cubic inches. How much bigger is this than that? Well, it's 8 times as big. Why would it be 8 times as big? Well, this side is twice as big, and this side is twice as big, and this side is twice as big as its corresponding side over here. So there's twice as much on the length, twice as much on the width, twice as much on the height. So the volume should be 2 times 2 times 2, 8 times as big. Volumes scale as the cube of the ratio between the sides. In the same way that areas scaled as the square of the ratio of the sides, volumes scale as the cube of the ratio of the sides. So if I tell you that here's some prism and here's some other prism, and this prism has a volume of 2021 cubic inches, whatever its dimensions are, doesn't matter. Its volume is 2021 cubic inches. And here's a prism that's made by, so whatever length, width, height are here, this is 3L, 3W, and 3H over here. How do we find the volume of that prism? Well, 3 times as big, 3 times as big, 3 times as big, 3 times 3 times 3 is 27 times that 2021, whatever that number happens to be. I should probably figure out what that number is because some commenter is going to say, hey, what's that number? And it's 54,567 cubic inches. So this is the way we go after volume. We imagine that we fill the space with unit cubes, and then we recognize that volume scales the way the cube of the ratio of the sides goes. Hopefully this is helpful. In the other screencast for this lesson, we're going to take a look at how to find volumes of certain specific shapes. Looking forward to seeing you then.